Hi all. In this series, we will discuss about the basic concept of SQL. Then we move on the intermediate concept, then the advanced concept. Because the overall idea to create this playlist to become pro in the SQL. So the SQL is very demanding language right now. I think you already aware about this one for data engineers, data scientists, data analysts. Every field in SQL is very important because we need data retrieval and use it efficiently. So the SQL is the right thing to choose for that. So that is the reason I think to prepare something for my viewers and it will be helpful for my entire data community, right? So the day one for the 30 days, I'm arranging all the things in a one by one in a small part of I assign to into small part that schedule I will share later. But today's I think I can share some of the basic concept of SQL. So we can start, right? Yes. So so these are the things I will discuss today. So we can start from the data and the basic concept of SQL. Then we move on the means in the queries. So basic query, then intermediate queries, then advanced queries. So that we can do. So we can start from the first one. What is data? So what is data? Just tell me what is data? Data is a piece of any information available in the world. So we can tell that the data, this is a kind of data. For example, Devi Krishna, my name. My name is a data, my age, my height, weight, and the data related to anything is means information related to me is anything considered as data. So the same thing we can we our house, our car, anything we consider the information we have is called as data. So data we can store in different things. We can store as a text file and PDF file and images, right? Images, video streaming, movie files. So that any kind of information we call right now as a data. Then you already aware about the demand of data is increasing day by or the generation of data generating the data generation is increasing day by day. So where we can store these kind of data. So that is the reason we definitely want a storage place. So that is called a databases. Databases is a systematic collection of data because if we consider our room, we are arranging our room in a systematic order. It will be more helpful for the user, right? For example, I'm entering to my room. When I am systematically arrange my room, my books are in a one place, my dress are in one place. It will more easier to me to handle this one, right? If I'm if I shuffle all the things in my room, it is not will not be work, right? It is what maybe taking lot of time. So that is the reason for the case of data, definitely we want to arrange these data in a specified order. For example, in my case, I want to store my personal details in one places, one table. I want to store my professional details in another table, and I want to store the extra my images in another table and another. So then there is an order, right? My personal record, my professional record, my images. So this is a different category. So if I want my professional data, then directly go the table, not want to go in the other tables, right? So there is a systematic database is a systematic collection of data. They support the storage and manipulation of data. Databases make data management very easy. So that is the main important point. Databases make the data management very easy. Let's discuss the database example. For example, I already told you, right? Telephone directory. In the telephone directory, if we store in a database, all the information, all the users who are using in particular telephone, for example, idea, their database contain all the users who made this connection. If the new user is entered for the connection, that also they can add. So that is the perfect example of databases. And Facebook. Facebook also store the different data of the users. For example, consider myself, I'm using the Facebook. So every data related to my is also stored in the Devi Krishna's databases. The relation I am related who are the person I'm related. That is the one table, the member table. It will store my friends list. That also store in another table, and the my member activities, that transactional activities or that kind of thing will store in the member activity table. And messages, what are the messages I send, so that also belonging to the messages table. Advertisement, lot more, so they are maintaining separate. There is a central table, me, my primary information, and they are distributing to the different table. So that is called as the databases. Then we move on the DBMS. So we already know about data, database, and DBMS. So how to pick the correct databases from a system of databases? So that is the reason we implemented our DBMS. DBMS means a piece of software. Database management system is a piece of software help to find the right databases. So that is the reason DBMS evolved is a collection of programs that enable the user to access the database, right? And manipulate the data, report, represent the data. So this also help to control. That means, um, for example, the person, 55 students are staying in a computer science classroom. So we can represent that computer science classroom as a computer science department. So here each student is considered as each databases, and the DBMS is the overall computer science department, like DBMS. That means that all the databases under one system is called DBMS. Then one more thing, RDBMS, Relational Database Management System. If the databases have some relation, we can call it as a Relational Database Management System. That means there is a relation, not more worry about this one. And non-relational database management system also there. So RDMS store data into the collection of table. This is very important. They store the data into collection of table, which is related by the common field between the common columns of the table. It also provides the relational operators to manipulate the data to stored into the table. For example, SQL Server. In the SQL Server or MySQL, we can see data are arranged in tables, right? We can create lot of table, but data must be arranged in a table. So that is the very important point. So all RDBMS, all the data are arranged in a different table structure. So they have defined structures. That is the reason relation is exist. Then we move on the SQL part. So we discuss about data, storing places databases, and they are connecting. To access the databases, we can use the DBMS system. If have the table, they are stored in a table, we can use the relational database system. And that we discuss. Then how we retrieve the data. Definitely, we want some medium to fetch the data, correct data from the databases. So that is the reason we introduce SQL, Structured Query Language. SQL stands for the Structured Query Language. It is used to communicate with the databases. This is a standard language. It is a language like programming language. It is also a language help to retrieve the data from the databases. For example, creation or insertion of data and updation of data, deletion of data. So that we can use this SQL. Okay. So we already discussed about the SQL part. Then we move on the table. So what is table? Table means in the relational database management system, the database table is a structure and organize the data into rows and columns. Each column means, for example, here I'm arranging the data. For example, employee ID, employee name, department wise, and the salary. For example, in the row column ID, the I only contain the ID. That means it will only contain the integer item or the big int item, right? Only that big int item will come in this ID. For name, we can only expect the string of characters. And department name also we can expect from the department name. And the salary wise, we are expecting the integer. So integer or float may be expecting, right? So this is the one we want to store in the kind of row column. But in the row level, we will get the correct record one by one. For example, this is the record of one employee. one employee, and this is a record of two next employee, right? So in this here we can say that table is the employee table, and the fields are ID, name, department name, and salary. And the data belonging to this column is this one, ID and name, department's name, and the salary, right? The columns called field but can have any number of rows that are called records. So I think hope you are clear about the table. Then we are moving on the primary key. For example, I will tell you what is primary key. Three kind of key definitely we want to understand: primary key, unique key, and foreign key. Primary key means we definitely want to identify each and every employee in an organization. So that is the reason they are distributing one ID card, right? The same thing, if you consider as a college, they are distributing an ID card too. Why? They want to know you are the only one person, means uniquely identify for their office uses and data manipulation. That is the reason we are getting this ID card. So here also each and every table, each record we want to analyze or we want to identify as a unique one. So that is the reason primary key is setting. So here you can see this ID is unique. Then if I'm selecting where ID equal to 10101, the Srinivasan record will be displaying here, right? So that is the reason of the primary key. The primary key may be the combination of field that uniquely specify in a row. This special kind of is a special kind of unique. This is also a unique key, but the only one condition, this primary key should not be null. That is very important. Definitely they have a unique value. And move on the unique key. Unique key means a column contain a unique keys. More than unique key, more than one unique keys must may be present in a table, but primary key. The primary key is also a unique key, but every unique key is not a primary key. That is the difference. That is very important interview question also. A unique key constraint uniquely identify each record on a database. This provides the uniqueness for the column to set of column. A primary key constraint has an automatic unique key constraint. This is defined as per the table, but only one primary key exists per the table, but different unique keys mean more than one unique key must or present in the table. Then the foreign key. Foreign key means the primary key of the one table, but that columns are present in the central table. There is a relation. When we need when we connecting one relation to one to other, then we are using the foreign key, because the foreign key is a one table which related to the primary key of the another table. The relationship need to be created. That is the main reason. Relationship. If we create relationship between the two table, we definitely want to maintain the foreign key. Okay. So we cover at almost basic concept. And one more thing. If you think about, we already talked about relational databases like spreadsheet, right? Then why we are using the databases? You must be thinking why we are using the databases. The answer is that we can upload the data into the spreadsheet. Definitely we can do, right? But the thing is that when we process or we can perform the operation, the spreadsheet will be lag. But if we use the databases, we can efficiently arrange all the things in a piece of computer software. And when we query the language, if we use the SQL, it will definitely help to data, retrieval of data. So that is the reason. That is the reason databases are using over the spreadsheets. Then we are moving on the relational versus non-relational databases. Relational databases we already talked about. Data are stored in the format of table structure. So set as a table. Table contain rows and columns. And they have the table has definitely a predefined structure also. So for example, SQL Server, MySQL, PostgreSQL, and MariaDB SQLi. These are the few examples of the relational databases. Okay, so we are moving into the non-relational databases. The non-relational database you can consider as the MongoDB, Cassandra, etc. For the non-relational databases, you can see that, for example, a lot of data are flowing through one by one. For example, images, video streaming, audio files, etc. How we can store these kind of data in a table? It is not possible, right? So that is the reason we introduce a lot of new efficient ways. So for example, MongoDB, Cassandra is the best example. So here the non-relational databases we are using NoSQL, not only SQL, is a kind of databases that does not use the table, field, and columns structured data concept from relational databases. Non-relational databases have been designed with the cloud in mind, making them great horizontal scaling because there are vertical scaling and horizontal scaling is there. Vertical scaling means we are replacing the one system with the another one. Then if we demand is increased, means 100 GB, if increases to 500 GB, we need to replace this system with a new one, right? That is vertical scaling. Horizontal scaling, we are adding the system 100 GB. We want to again 100 GB, we are adding the system. If we want another 100 GB, we are adding. Then we can consider these three system as a one system. So that is horizontal scaling. So when we introduce this MongoDB, this horizontal scaling is possible. That is more efficient than the vertical scaling. So that is the reason it is quite popular. And NoSQL databases we can consider as when you think about, we mentioned about data in the previously, data was arranged in a table structure, but after that things changed, right? The data will get as a document. That is one possibility. And data are stored in a key values. For example, key and value we can store in a column level. One column we can analyze the data, and graph database means in the elements are stored in a different node. For example, Facebook, the members are arranged in different. Each member is a each node, and the relationship we can call as the uh, links, right? So that is called as the graph databases. So these are the four types of databases in the NoSQL databases: document databases, key value store, column oriented databases, and graph database. These kind of things definitely we want to discuss in the coming structure, but we now you have a basic idea. These are the structures databases available. Then we are moving on the cloud database. We already aware about the cloud is very fast moving right now because people are migrating the data from the on-premises system to the cloud, because cloud is more safer than the on-premises because it does not affect any kind of um, means disasters. If disasters happen in the one places, it will definitely affect the servers in the on-premises system. But if we store the data in the cloud, the advantage is that there are a lot of replica we can generate. Then if any place we face any kind of disaster, it will be we can take the data from another place. That is a very important concept. So that is the reason the cloud migration. For example, the cloud providers like Azure, AWS, GCP, they are also provide the databases also. For example, Azure SQL databases, Amazon Relational Database Service, and Google Cloud SQL. And the IBM Oracle databases, Google BigQuery, Amazon Redshift. These are the examples of the cloud databases. Then we are moving on the SQL command. These are the basic SQL, 5 kind of commands we want to understand. Then only we can efficiently write the programs. So the first one is DDM. This is also very important interview questions. So definitely you want to understand DDL, data definition language, DQL, data query language, DML, data manipulation language, DCL, data control language, and TCL, transaction control language. So here you can, data definition language means create, creation, data definition. When we use these command for the define the structure of the table, or we have modification, make some modification of the DDL, data definition language. Create, drop, alter, and truncate. This kind of statement has a power to effectively change the structure of the table. So that is the reason DDL. They are called as DDL. DML means data manipulation, insert, update, delete. DCL uh, data control language. So help to controlling the data flow. TCL, transaction control. TQL, data means select statement is definitely we want to know, right? Because the selecting the item from the database, but depends on the query, depends on the item we are. For example, having we can add where, like, and different kinds of we can add. Depends upon the that one. The data is retrieving is different. So here you can see that DDL, data definition language, for example, simply deals with the description of database schema and is used to create and modify the structure of the database object in the databases. For example, create is used to create the databases on the object like table, index, function, views, store, procedure, triggers. And drop is simply delete or drop the table from the database object. Alter is structure. Once we create the structure, after that we want to add some more items, some more columns. That will happen, right? So that time we can use the alter statement. And truncate. Truncate, we can remove all the record from the table, including the space, all the spaces allocated to record and remove. Okay. And the comment is used to add the comment to the dictionary. Then DQL means data query language, that is selecting the data from the database, only the select statement. But after the select, we can use the join query. That is very important. Windows function and like operators, having operator, where condition, etc. So that is the reason the select has weekend flexibility with the adding lot depends upon our requirement. We can add the operators. So that we discuss in the later videos. Then data manipulation. Data manipulation for the data present in the DML with manipulation, including the SQL statement, insert, update, and delete. And DCL, data control language. So definitely we have DCL include the commands like grant and revoke, which mainly deals with the write permission and control the data. Normally admin have the access, right? So sometime definitely we want to grant the access to the particular user to access that directory or the table. The grant give the user access privilege to the databases, and revoke withdraw the user access privileges given by the grant command. Next one is TCL, transaction control language. TCL command deal with the transaction within the databases. Example, commit, rollback, save point, and set transaction. Commit means commit a transaction. Rollback, once you complete this one, rollbacking the transaction in case of any occurs. For example, if you are transferring one money from you to your friend, the middle of that one, the net was slow and the transaction was failed. So what happened? There is a rollback. Definitely that money credited to your account and it will not go into the your friend's account, right? Because the middle of that transaction it was failed. So that time the rollback operation that also very careful. Otherwise, the payment system, entire payment system will and the trust of the users will break there, right? That is the reason rollback is important. Save the point. Let us save the point within the transaction, and we can set a transaction. Specify the characteristics of the transaction. For example, if you set some transaction in your account, right? They are connecting to your databases. For example, if your set transaction limit is 1 lakh, that data definitely pass to your database system. Then only will not after the more than 1 lakh, it will be showing some error. So that is doing in the front end part. So that kind of thing included in the this part. I think hope you all clear about the basic concept. Then the next videos we will discuss on the more advanced concept. We want to write the queries, that kind of thing we will do. Yeah, if you have any doubt, let's comment below. We can do it.